We are going to prove that xm, which is this highlighted section, equals xy over 2. So we always start with the given, and let's write the given. M is the midpoint of segment xy. This is a given. So based on that, what can we conclude? We can say that segment xm is congruent to segment my. This is the definition of a midpoint. Also, we know that xm equals my. Remember, xm and my without the segment sign really stand for numbers, and this is definition of congruency. From previous knowledge, we know that xy equals xm plus my. This is segment addition postulate. All right. So I'm going to look back at what I need to prove. I need xm and xy. So what do I not need here? Oh, it seems I don't need my, but I know from step 3 that my equals xm. So what I'm going to do is I am going to substitute xy equals xm plus xm, substituting in step 4 using step 3. So xy equals 2xm. You can say combine like terms, or definition of addition. Sometimes you'll even see that being stated as the distributive property. So now if we divide both sides by 2, we get xy over 2 equals xm, and this is the division property of equality. Well, I don't have quite what I need yet, but I can easily do that. I'm going to include step 8. If I switch these two around, the equal sign, I can say this is the symmetric property of equality. Okay, let's go to the next proof here. let's start with the given. Angle 2 is congruent to angle 1. That is a given. So this means the measure of angle 2 equals the measure of angle 1. Definition of congruency. I can switch these around an equal sign, and that's called the symmetric property of equality. And finally, I can say angle 1 is congruent to angle 2. That is definition of congruency. So essentially what I've proven is the symmetric property of angle congruence.